it's only 5 questions.
This call is now being recorded.
Oh, that was weird. Being that it's only 5 questions, we can actually kind of go through all 5. I know the solutions have been posted, but this way we can kind of see the process for how every question was solved. Okay. All right, let's get rolling. So for number 1, we're looking at, and you saw questions like this today, right? We call this lesson, this topic, exponential growth versus exponential decay. In this case, we have growth. We have growth because the base is a number larger than 1. We have 1.055. And we're asked, what does the 14,500 mean? What does 14,500 mean? So anytime we have that number out front, and this is the same if it was just a normal exponential function, that number out front, which we call a usually, is going to represent the initial value. So in this context, it would be how many, let's talk about population, how many people were there in the start? How many people were there in 2019? Okay, the original population, whatever you want to call it. So the number out front is always going to represent the start of something. If we're talking about money, that would be like your initial investment. When we have like science type problems where we're talking about the decay of an element, that would be like its original weight or something like that. What is the percent change? Okay, there's a lot of answers here. We could say, what am I missing? What are we saying? Okay. There's a lot of answers here. We could say like 105.5. We say 0.055. Like there's a lot. We know to look in the parentheses, but what exactly do we pull out? Just like if it's decay, we say, hey, what's missing from 1? Be careful, Nolan and Rachel. With growth, we want to say what was added to 1. So what you can do, if you were here yesterday, we suggested the same idea. Subtract 1. Yesterday it was like 1 minus whatever, was less than 1. This case, we're going to do that number minus 1. Basically just getting rid of the 1. Hopefully you don't need to grab a calculator for that. All right. So that's what it is as a decimal. Now making it into a percent. When we make a decimal into a percent, we move the decimal 2 places to the right. Basically multiplying by 100. Don't chew on that, please. That's not. Don't tell you. Okay. And that will become 5.5%. Okay, 5.5%. I know I'm writing sloppy, and the answers are up. I'm just kind of explaining everything. Between the years 2022 and 2025, what is the AROC, average rate of change? So we know the change in years already is going to be 3 years, right? But we want to find the change in the Y values. So what we're going to do here is evaluate P of 3 and P of 6. I'll go to my answer key for this one. Oops, that's not it. Here we go. So why am I pulling up P of 3 and P of 6? Because 2022 would be 3 years from 2019. 2025 would be 6 years from 2019. Now you need those Y values. Average rate of change, remember, is just like slope. So see why I wrote AROC equals delta Y over delta X. So I needed those outputs to figure out what the change in Y was. This is an increasing function, so the AROC should be positive using that kind of common sense logic. We know the change in X right away was just 3 years. It's a difference of 3 years. So expressing that ratio, and says nearest tenth, would be 998.9. 998.9. Okay? AROC slope, delta Y over delta X. I think one thing that people make a mistake with AROC is the idea of like positive and negative. A few people did it on the quiz. Whichever order you're subtracting, you have to keep it consistent. Or use common sense. What do I mean when I say use common sense? You know this function is growing. So if I got a negative for part C, I would be like, wait, how can this be going down if it's a growing function? So use common sense in that light. So what is it saying here? So what that means is like about 989 people are coming into this town every year, or I guess being born and stuff too. Right? It did say to round to nearest tenth. I know we say like it doesn't make sense for decimal people, but they said to round to nearest tenth. Kyle, or was it Kyle?
Yes. If it's decay, for example, if it was like decay, do we write 5.5% decay?
Right, but it wasn't decay.
Oh yeah, I know. I'm saying if it was decay, do we write the 5.5% decrease?
Yes, yeah. But it would, you're aware it wouldn't say 0.055 in that case, right? It would be like 1 minus 0.055, and you would see 0.945 in the bubble. You'd see 0.945, kind of like some of the questions you saw today. The grades have been released, guys. I don't know if you're aware of that. I obviously can't put it in pupil path. I don't want to put in you got a 30 out of 50 on your test for obvious reasons, but the grades are released. You might have to either go back into Edge Elastic if you want to see what you got wrong, or it actually says it in Google Classroom, which we don't use. Yeah, it says it on Google Classroom. Not that I use that grade book, but okay. Are we good with that? Just kind of analyzing either a growth or decay model. Number out front is the initial. The base will tell us the percent. If it's growth, it's a little bit easier. If it's decay, I recommend doing 1 minus. If it's like 0.83, do 1 minus just so you clearly get that 0.17. Sometimes we have trouble kind of seeing that. Questions with one? Okay. With number 2, this should be an easier question tomorrow. If I present some sort of table data in front of you, deciding if it's linear or exponential. Deciding if it's linear or exponential. So how can we do that? It might be easy. I'll give you a hint. It might be easier to prove which one it's not to start. How can we prove which one it's not?
By looking at the change in value.
Good. We can say, hey, this is not going to be linear. Hold on. One second. We can say that, hey, x is increasing by 1 every time. And we can even see, before I even do the math, I see, all right, this is going down 15, which means this if this is linear, since it's same pattern up top of +1, it should be minus 15 again. Without even touching my calculator, I know that this is off. Because minus 15 from 35 would be 20. So I know this isn't linear. So that's why number 2 we said is exponential. Okay, doesn't hold up with the pattern of constant rate of change. I wrote exponential. You want to be, when it says explain, remember tomorrow's not like ABCD, you got to explain. There is a non-constant rate of change. You didn't have to add this, but I did add in, like, technically you're multiplying by 0.7. Let's say you really want to come up with, hey, where did you get 0.7 from? If it's not obvious, like times 2, times 3, times 4, whatever it may be, an option is to divide. So if you can't tell what you're multiplying by, divide. Do 35 divided by 50. And you'll go, oh yeah, it's multiplying by 0.7. Not something that any of us would be able to see, but now we can. Okay? So make sure I know this is tough sometimes because we're not in person, obviously, all of us, and the explanation part we might be lacking a little bit because we don't really do that as much, but make sure you explain. You don't want to lose points on this one because you write exponential because it is, right? We want to give a clear explanation there.
Mr. Rice,
Yes.
I did have a question about number 1. I had my hand raised, but I guess you didn't see it. It's fine.
Sorry.
So where did you get the 6 from? I'm not understanding. P of 6 for number 1, part C.
In 2025, that would have been 6 years because this problem was talking about 2019. So that would be 6 years in the future. Just like how 2022 was 3 years in the future.
Okay, and for number 2, you wrote as an extra thing, there is a non-consistent rate of change and a common ratio of 0.7. If we have to make an explanation like that on the test tomorrow,
Right.
Will we have to write that out?
Yeah, if you have to explain, you can't just say exponential. We're not going to award you for let's say I go, hey guys, is this true or false? Explain, and you just write true. We're not going to award you for like a 50-50 guess. So the explanation is really where all the meat of this problem is.
We also have to say the exact rate of change and
No.
the common ratio.
Technically, I could have just said exponential because there's, there isn't a slope, but there is a non-constant rate of change. That would have been enough. I did identify the common ratio, but that's a little extra.
Thanks.
No worries. Okay. 3 is where we get interesting. So let me go back. Let's do it like pretend we're doing it for the first time. So number 3, we got 2 stocks. We got Desmos Inc. and Wolfram Alpha. Wolfram Alpha is another good math site. Desmos is $75, and it's going to increase by $125 at the end of the first month, and every month after that. So plus $125 plus. So right away, what are we thinking in the back of our head for Desmos? Yeah, there will be partial credit. This is going to be modeled by linear. I see the idea that, hey, basically plus $125 every month. When you're writing a function, I'm just going to make these numbers up just to make a mistake quickly. So these aren't actually... What would be wrong with this? So let's say I went, all right, that's Desmos, that's Wolfram Alpha. This is very common. What would be wrong with that?
That's not a linear function.
Yeah, it's not a function at all, right? These are both expressions. Sometimes we get so hung up on like, oh, did I do it correctly? Is it +5 or +4? Did you write it? Do we even write an equation? No. So make sure you write an equation, and also make sure you differentiate the two. Like I probably wouldn't want to do this either. Right? Because I'd be grading it. I'm like, okay, which one is which? So maybe do something where it's a little bit more clear. Like I think I did on mine. Did I? D of X and W? Yeah. Okay. Or maybe add a note like, hey, by the way, this is Desmos and this is like, make it clear. Obviously with D of X and W of X, it is pretty clear, but it can't hurt to play it safe. All right. So Desmos, I put $75 plus 125x because that's the rate of change in this problem. That's the slope. 75 is the initial. For Wolfram Alpha, it says 15 to start. So remember the initial value is going to be 15, the number up front, and it's going to double. Double, if you didn't know, means times 2. So our base, our common multiplier is going to be 2, and then our exponent is going to be x. Now, you don't need to make any adjustments here. You don't need to say x plus 1, x minus 1, like that virus problem, because we're saying like at the end of the first month. So there's no need for adjustments. There's not going to be any tricks or weird curveballs like that tomorrow, just like how this problem didn't have it. So those are our 2 functions. Any problems with A? For 4, Steve wants his stock to be $900 at the end of month 6. So obviously we're going to evaluate 6. I would type these into y equals, and see what happens at month 6. So for Desmos is at 825. Okay, not quite enough. Wolfram's at 960. He can choose that option. So if you're asked to evaluate them, don't try to do it by hand. Just use y equals. Write down what you observe, but you certainly don't need to show every single little thing. There won't be adjustments on the test, no. It's because, Rachel, the phrasing of at the end of the first month. So like when I plug a 1 in, it's okay that it gets $200 because like they're saying, this happened at the end of month 1.
What are adjustments?
What?
You said there won't be adjustments, but what are adjustments?
What are the things that we don't even know? Remember that virus problem on the homework where you had to do like x plus 1 or x minus 1?
Oh, yeah.
Yeah, so like that.
Wasn't there one on the test too?
We haven't had a test on this topic yet.
No. For the multiple choice, I'm pretty sure I saw it answer was one of them with that adjustment.
Yeah, that's something else. Those are called enhanced, where you rewrite them. Those are enhanced. That's not what we're talking about.
Okay, I see.
That was actually from a Regents grant. I know it's probably not very appropriate that said virus A and virus B, but I didn't even make that up. That was from like 2 years ago. Okay. On this portion, no. So this portion will match like the review sheet. So let's just recap. All right, analyzing a decay growth model, deciding if something's linear or exponential, modeling functions, we call this, like taking a scenario and writing an equation that models it, graphing an absolute value, some transformation stuff, and then a piecewise. So what I just said, what I just counted off is what you'll see tomorrow. Okay, for graphing a piecewise, not graphing a piecewise, graphing an absolute value, I didn't do it here. What was I doing up top there? I don't know what that is. You can make a table of values. I didn't do that. I would recommend, okay, making a table of values. You don't have to go this crazy with points. I have like 37 points. You don't need to go that crazy. You also don't need to label. I don't know why I label, because then you guys get like label happy. The transformation here, the +3 is going to be our IHOP rule of moving it 3 to the left, opposite of +3. The -5 is going to move 5 down. And what have I told you guys with this topic? If you're having trouble with the transformation, look at what you just graphed. Look at what you just graphed. There should be no reason why you go like, oh, 3 to the right. Like look at the picture in front of you. You don't need to label, no. If g of x is half of f of x, so what would happen if you multiply the entire thing by 1/2? We know that when we throw numbers between 0 and 1 in front as coefficients, it will make the graph wider. Vertical compression, if you want to sound fancy. Okay? And you can test that out. Like, let's say you weren't sure, like type in 1/2 and then type in the, f of x equation. And you'll see, oh yeah, it did get wider. Remember when you're making your table for this, you want to choose an appropriate table. Should I? So what do I mean by that? Like when you're typing this into your calculator, what do we want in the, this is weird with absolute value. You actually want to start with the center. What do you want to be in the center? Not 0, not 0. Generally speaking, well, -3 in this case. What you want to be in the center is the vertex, what's called the vertex, where the point of symmetry occurs. Yeah, like -3 in this case, Rachel, good. But that's going to be, if this is what you guys meant by 0, I like to say the vertex will occur where the absolute value is zeroed out. Not necessarily where the function equals 0, but where the absolute value is zeroed out. Okay? The other way I suggest finding this is just scrolling up and down your calculator and looking for the symmetry and be like, okay, here it is. It's centered out. I got that middle point. I got the rainbow of values around it. All right, so just be careful with that. If you graph it and it looks like a line, you chose a poor table. You probably just wrote down 1, 2, 3, 4, 5, and that's why you're getting like a line instead of a V. Are we good there? Questions with number 4?
I have one question. It's about the graphing calculator.
Right.
Is it possible for you to explain or show us how to find the symmetry on the graph?
So one way is to look at the absolute value, like without even touching a calculator. Look at the absolute value, just the bars. Do you see what I'm talking about?
No.
The bars in the equation, the x plus 3.
Oh, yes.
Whatever that number is, the middle of your table will be the opposite of that number. So, for example, Maximus, tomorrow you have, let's say, I'm just making this up, x minus 7 plus 2. What would the middle of your table be? What value should be in the middle of your table?
Positive 7.
That's it. Okay. The other way, I'll do this quickly. Someone give me some. Oh, wait, hold on. How do I do this? No. Oh, hold on. Someone give me some transition music here. Okay, hold on. You ever notice that, like, when teachers are trying to present something, they always go like, they make some like awkward like. Or they're like, just give me 1 second. I think we should be good. They like talk weird. Okay. So I got my calculator open. Can someone give me a calculator? Can we see? Can we see the calc?
Yes.
Yeah.
That's a little weird because I'm streaming from my iPad. Okay. So y equals, this was something from yesterday, I guess. I'm gonna hit math, scroll to the right for num, ABS. The older calculators, if any of you still have, will actually still say ABS. Now they do like, they actually give you the bars, but the old ones like mine, the TI-83 I used to have, it would say ABS just like it did in the choice. And now whatever the problem was, they don't have, oh, x plus 3 minus 5. Okay, be careful with typing in versus out. For example, let's say you just like, you type really fast and you might have typed that. So make sure when you want to move out of the brackets, you hit the like, you hit the left key to go outside the brackets. Now we'll go to oh. Now we'll hit second graph. We don't really care about what the graph looks like, so just more so the table. And if you scroll up and down, you can start to see that symmetry. Where I have my cat, not that you would need to copy a table this extensive, but where my whole table is right now, notice how in the dead center, everything around it starts mirroring. So that's what you would look for as a table.
Okay, thank you so much.
No problem. Yeah, just like something went down the wrong pipe. Okay. Let's go back to my iPad. Okay, so that's absolute value. And last, our big boy of piecewise. Okay, so for piecewise functions, all of this stuff in purple, it's not like, oh, maybe you could show it and, you know, it's not a big deal. You pretty much have to do this. It's very, very difficult to do piecewise like on the fly, unless you're like, you know, a expert level with these. So you're making these, I call these mini tables. You're making these mini tables. Okay? You're making these mini tables. Now with mini tables, there's a few things to consider. One, what I always say, regardless if a number is included or not, it should be in your table. Regardless if a number is included or not, it should be in your table. The common mistake people make for like the first function, they go like, all right, it can't equal -1, so I don't want to put that in there. You still have to put -1 in your table. It's just that you use an open circle. All right. Equal to a number is just going to be a horizontal line, so that should be easy to graph. The output is always -2. Goes on forever. There's no restriction on how small it can be, so that's why we have the arrow on the left. The middle function here we have is exponential, 2 to the x power. Remember, with anything that's nonlinear, you can't use that trick of like, I'll use the beginning and I'll use the end, right? Why can we not do that? Because that's going to make it a straight line. So yeah, it's a little annoying, but you just have to copy down all the points in between, close circle, at -1 and 3, because it is equal to x minus 4, make a little table for, starting with 3, right? What did we say? Regardless if it's included or not, it's got to be in your table. Choose a few numbers larger. Doesn't matter if it goes on forever. Just choose a few, 2 or 3, and connect. When you're plotting your piecewise, I recommend doing one table at a time. Double check it. Plot it. Look back. Okay, is everything good? All right, move on to the next one. All right, plot it. Is everything good? You just start plotting all 20 points, it gets very hectic. Now, the analyzing part. Where does find n of -1? So -1 is right here, right? We have two options. I'm going to choose the closed circle. So this function, which was included, the open circle isn't included. That answer should be 1/2. Where does n of x equal 1? That happens at 2 spots, so be careful. There can be multiple answers here. It equals 1 here and here. All right? Sometimes it might not seem like, I'll give you another example. Hold on, let me catch up. Any questions with that so far? Zoom out. Okay. Be careful with questions.
Mr. Rice.
Hold on one second.
Okay.
With questions like B, like this one was pretty obvious, like, okay, there's 2 spots. But let's say I said, like, where does n of x equal, 1, 2, where does n of x equal 8? So what people would say is, they go, okay, it equals 8 right here, that's it. So whatever that is, the answer is 3, n of 3, right? What's the flaw there? Can anyone tell me why that's a mistake? That is true, but you're missing one. It's pretty obvious that even though this line stopped, and this line was graphed perfectly fine, there's nothing wrong with it. This line is increasing. It's eventually going to hit 8, right? 8 is like this invisible line right here. It's going to hit it. We just can't see it. So what you could do in that case is maybe type x minus 4 into your calculator, y equals. Not that it's super complicated, so you could like set it equal to 8 and solve it, and you'd be like, oh, when x is 12, it will hit 8. So look out for things that might not be like super visual on your graph, but that once again, you could use common sense to say like, oh yeah, it will, it might hit there. I see that it's going up. I know for a fact that, this isn't moving. This isn't going to ever hit 5 or, something else like that. So sometimes you might have to kind of, I don't know what phrase we want to use there. You might have to be able to see what happens outside the box. Maximus, what was your question?
I'm still not really understanding how you did whatever number this is, part A, I believe.
So n
Number 5, part A.
n of negative 1 means when x is negative 1, where is the graph? What's the y value of the graph? So let's go to where x is negative 1. That's right here. The graph is seemingly at 2 spots, but one of these spots is not included. We don't want to count this one. So the y value there, I would just refer to the table you had earlier. The y value at negative 1 is 1/2. Maybe did you have a question? I'm pouring a little bit.
What like finding a value that is like the example you gave a few minutes ago, would something be like it on a test, or is it just like some kind of example for like later?
I don't know.
Okay, thank you.
I don't know. Yeah, it could be. It could be. We don't know. I haven't taken the test yet. I failed the multiple choice today. Okay. Question. So that's everything with the review. Do we want to... Let's do some practice, I guess. Hold on. Okay. So let's look at an exponential function. Let's call it d of x. This is stock price, let's call it. So we'll say 560 times 0.9932 to the x power. Let's find the rate of growth or decay as a percent. And let's find the average rate of change in this interval. We'll say from 2 to 7, rounding to the nearest tenth. Okay, try those 2 questions. When somebody talk, yeah, you can hear someone talk in the video. I mean, if you have a problem, I can try to mute it, but I don't think people mind if their voice is in there. I also don't think random people are going to watch this. It's just going to be people in our class. It would be weird if random people are watching our extra help videos. At 590. 590.
Wait, you can't put it as a negative, right? So you could just write decay.
Yeah, don't say it's negative. Okay, so the rate of decay, what we're going to do once again is basically say, hey, if it was 100%, it would be full. So if it was like 1, it would be 100% here. So this is clearly decay. So we don't make any mistakes and say like 93.2. Let's figure out what's missing from the base here. What was taken away from 100%? The answer should be 0.068. That's also not our answer because that's a decimal. We want to give it as a percent. The rate of decay here is 6.8%. You don't say negative. You just say the decay rate, or the rate of decay is 6.8%. If it's 1, then it wouldn't be changing. It's not exponential. 1 to the x power is just going to be 1. Yeah, that would be a silly function. Okay, now for AROC. AROC, we need delta y over delta x. Delta x we can already figure out. We know it's between 2 and 7, so what's the change in x? 5. For the change in y, we need to know what d of 2 and d of 7 are. So I would grab a calculator, type in the function, but replace x with a 2, and then type it in a second time and replace x with a 7. Save them in your screen, don't clear it out. This way we don't have to write the decimals down. 2, 560.92 to the something, 7th. Okay, minus 46. .4294. Okay, so this should be negative 144. Remember, don't round until the end of a problem. Rounding to the nearest 10th doesn't mean every step gets rounded to the nearest 10th. And now we could divide by 5. I'll talk more about why this is negative. Your answer here should be negative 28.9. Negative 28.9. So why is this negative? 2 reasons. 1, we know it's decay. We could use common sense and say, hey, it's going down, it's decreasing, it should be negative. Second reason is, if we're doing 7 minus 2 to get 5, that means we have to start with the 7 when we're subtracting our y values. The 7 was like 342-ish. The 2 was 486. So we have to do it in that same order. Yes, this will be on the test. How'd you get negative? Yeah. So common sense, it's going down. Or second reason would be keeping that same order. Remember what I did for slope, what I told you guys? Like, hey, it's helpful to have it like this. That might be another idea. Like, all right, this was 2. That was 7. I'm just going to write like the whole numbers. So now this way you don't mess it up. You're like, all right, this is plus 5, but this is minus, 100 and whatever it is. So that's what I mean by be careful with your order. People did that on a quiz. They put like positive or it's negative or vice versa. Yep. The y, where did that number come from? Subtracting those 2 values, Lucas. So you had to, for d of 2, you had to like plug in a 2 to this equation. I would just use like your home screen. And for d of 7, you have to plug in a 7 for x. And then you're it's about 486, and the other one is about 342. They're kind of messy. So that's where the 144-ish comes from. Studi, go ahead.
Will the question tell you if you have to round to the nearest hundredth or the nearest whole number?
If you have to round, they have to tell you.
Okay, thank you.
Okay. Other questions? Other questions? We'll do, let's take a look at another piecewise. Let's do a piecewise, and then we'll kind of wrap up. Yeah. I don't have any carrots. Okay. So let's look at a piecewise. Maybe not. Okay, revisiting, yeah. So I'm using this lesson because I know we didn't get to everything. Which one did we not get to? We didn't get to a bunch of these. Okay. Let's try this one. This would be like something. This is annoying. Okay. This will be something that you'll see. Ignore the increasing part. We're not going to see that. So after you graph your piecewise tomorrow, you're going to evaluate like what we saw in the review sheet. Like, oh, what is J of 2? Where does J of X equal 5? Ignore the increasing part. We're just using this for the graph part. Okay. So let's start. We'll do this all together. So we're going to make 3 mini tables. One of them is called 1/3 X. One of them is called 1/2 to the X power. And one of them is called negative X plus 7. To make your 3 mini tables. How many people are here? Oh, 36. Okay. I never checked that. Now, the most important part of this problem is choosing which X values go in your table. So let's start with 1/3 X. Can anyone tell me what's the kind of key point I have to have in my table? Is one key point. The rest of the points actually don't really matter. Like you have some freedom. What's the most important X value in that first table? -3. Even if this wasn't here, we would still put -3. We would just use an open circle. But especially now that it's included, we're going to put a closed circle. And now we want to choose a few things that are less than -3. And I could be selective here. Because I see the 1/3, I'm going to choose multiples of 3 to make this work out nicely. You have to do that? No, but it will work out. You know, I could do this mentally now without even a calculator. So this is going to be -1. This is going to be -2. And this is going to be -3. And that's it. Okay, this goes on forever. Let's go ahead and graph this. Okay, closed circle, normal dot is fine. Now, half X. Half X, remember, it's exponential. We can't use like, oh, just use the beginning and the end. We have to put, oh, it's not included. Do we not put -3? No, we still put it. Still put it. And we have to go everybody in between. We have to hit every step. -2. Not that there's many steps here. -1. That's it. Okay. Now, I would probably use a calculator here if you need to. So like second graph, type it in. Second graph, look at the table. It's going to be 8, 4, and 2. And what type of circles is the middle function going to have? What type of circles at the 2 boundaries? What type of circles? Both open, both open. Let's go ahead and graph this exponential, keeping in mind this is kind of a brief exponential. So it might not look like super curved because it is only 3 points, but we'll try to make it as curvy as we can. All right, put a little bit of a bend to it. You don't want to try to connect that and make it like a straight line. It's a little sloppy. What I'm saying is you don't want to like take a ruler and connect that. It's supposed to be curvy. That's fine. It's kind of hard to connect because it is only 3 points. But those are both open. Okay. And for the last table, can anyone tell me for the last table, what X values should I have? What X values should I have? Definitely have to have a -1, and then choose like 1 or 2 more that are larger. There's no tricks here of like multiples or anything. So like, all right, 0 and 1, that's fine. Your outputs here are going to be 6, 7, and 8. So -1, 8. And we're going to have a closed circle, and this one's going to go on forever. The -1, 8 is closed, going on forever. 3, 4, 5, 6, 7, 8. You can use slope if you notice a linear, like for example, as I'm plotting that one, you could say to yourself like, all right, the slope is -1. So as you're plotting it, you could use that to your advantage as well. If something looks weird and you're like, wait, that's not a slope of -1, that can maybe, you know, help catch a mistake. Lucas, it's like cutting people's, is that Lucas? Go ahead, Lucas.
Yeah, how do you make fractions on the calculator?
So there's a few ways. One, the way I do it, someone had a better way, but it didn't work on mine. If you hit alpha y equals, you get a screen that says ND. I'm not going to switch to my calculator to show you, and then you should be able to like type in fractions. I never, to be honest, I never do that myself because I just type the divide button. It works. So like 2/7, I'll write 2 divided by 7. Alpha y equals, yeah. What was the other one? Alpha x? Yeah, that doesn't work on mine. I don't know why it works on maybe newer ones. I have a plus CE too. It doesn't work on mine. Okay, that's our graph. And then what you'll see tomorrow is like a follow-up of like, let's do one like Maximus was asking, like, what is, you know, what was this called? J? What is J of -3? So when you go to -3, you have 2 choices. You're going to choose the closed circle. So you'd say J of -3 is -1. If I said, where does J of x equal? Oh, okay, this is a good one. Where does J of x equal -1? Take a minute for that. This is super sloppy. But where does J of x equal -1? Where does J of x equal -1? Yeah, so this is kind of like what I was talking about earlier. Obviously, we know -3 is an answer. We just said that. But there's another answer. X equals -3. People might just circle that and be like, all right, I don't see anywhere else that it hits -1. I can clearly tell that this line is, you know, on a path to hit that. So what I'm going to do is say, all right, I know it's going to hit, but I can't quite tell where. You could either look at the function rule and say to yourself, all right, what can I plug in there to make it -1? The answer is going to be 8. The answer is going to be 8. So you have 2 x values where this function equals -1. It was open before. What did happen? Wait, what? Yeah, this is going to be on the test. I don't know if this is news to anyone, but the questions we do during extra help are going to be on the test. If you're playing like, you know, I hope he doesn't put the piecewise, it is going to be on it. My reviews are very like, very black and white. Like it is what it is. If it was on the review, it's going to be on test. Yep. All right. Oh, go ahead.
I kind of forgot. I was just thinking about it, so I got confused. But when J of x, when it's like asking if for finding a value, or like the equation J of x equals -1, are you looking across the x-axis to look where the y-axis hits it? I mean, or like is? If that makes sense.
Yeah, so when you're asked where does J of x equal -1, what it's really saying is like imagine like imagine imaginary line. Picture an imaginary line like that, and it's saying, you know, where does this function hit that line? So we clearly see one. We don't see another one just because we kind of stopped our line a little short. But we can tell that if this line were to continue, it would hit. So you could either extend your line a little bit, or you can look at that equation in particular and say, hey, where would you equal -1 and solve that little equation.
Okay, thank you again.
No worries. All right. Any other questions? People that are who's here? Let me see who's here. I haven't even looked at names. Coop, what's up, Coop? Which class has the most people here, I wonder? A lot of 24. Pretty equal. Pretty equal. Okay. Any other questions? That's everything I have. Any other questions? So 5 questions tomorrow, very, very similar to the review. That's everything. Don't look over the quizzes. Don't look over day 1. I mean, there might be some overlap of topics, but I would specifically focus on the day 2 review because that was constructed, looking at the test. I had the test. I made that review sheet based on it. So I'll give you a very clear idea. Whoever has their hand up, go ahead.
Can you redo 1C?
Can I redo 1C? Who was that?
Natalie?
1C from day 2?
Yeah.
1C from day 2. Okay. 1C from day 2. Okay. So this is just an AROC question. That was kind of like the one I made up again. Remember, like the one I just kind of wrote on scratch paper here? So with AROC, we want to find the difference between the X values. In this case, it's 3. And the difference in the Y values. Then it's like slope, delta Y over delta X. To find the delta Y, that's the tricky part. You have to use your calculator. So you're going to type in a 3. Reason being, 2022 is 3 years from 2019. 2025 is 6 years from 2019. Type it into your calculator. You get those 17,000 and the 19,000 numbers. You're going to find the difference between them, subtracting, just like how you did 6 minus 3. We're going to start in that order. So start with the 19, subtract the 17. That's where 2966 comes from. That divided by 3 is where we get our answer of 988.9. It's important with average rate of change that you keep the order consistent, or that you think about like, hey, is this an increasing or decreasing function? So in this case, we can tell that it's increasing because the base is 1.055. So we know it's going to be positive if for some reason you accidentally put a negative sign. Okay. Did that answer your question, Natalie?
Yeah.
No worries.
Is there any way to read graphs better on the TI-84? Because whenever I try to trace out the line, what happens is it always gives me like these weird numbers.
Right. So
0.9.
Yeah. I know what you're saying. So the trace feature is like good for some things, but you shouldn't really be using that. If you're trying to find values of this, the table is a lot better. It hits second graph. I almost never look at the graph, even like throughout high school. Like we don't really care about the graph. It's more important about the table. So hit second graph. It's not. I always say like it's not like you can print the graph. Why do you care what it looks like? You need the data behind it. So you need the table. So the trace you can kind of like follow along the graph, but the trace gets kind of ugly.
Thanks.
No worries. All right, guys. I think we'll call that. This is an intense extra help. Thanks for joining, and hopefully if you look these over, you should do fine tomorrow. Timing should be good too. 45 minutes to do 5 questions. You could do the math there. We obviously know Piecewise takes a decent amount of time, so make sure you leave enough time. If something says explain or show work or something, make sure you do that. Yep, exact same format.
Which example was for Piecewise again? Like which question?
Number 5. 5. They're about the same difficulty. All right, guys. Everyone have a great day. I'm going to stop recording.